Welcome back to our learning session for our language. Today we'll be going through the exercises for Module 3. These are homework exercises for Module 3. We're going through that exercise today. Let's go through question 1 through 4. Before we begin, we need to make sure that we are removing any list of data that has already been loaded. So let's remove those data that has been loaded into the memory. Here we go. For that, we need to do rm list equal to ls. And when you do that, it's going to remove all the data that has been stored in memory. Now, next step is to load a library for utils and tidyverse. And we're going to do that. Let's load the data, load these libraries into the memory. Third step is to load the working directory into memory, and for that we will load model 3 working directory into the memory, and this is it. But we need to replace the backslash with forward slash so that it doesn't complain. I think this is the last one. Now let's run this command, and there we go. Model 3 is now our current working directory. Now next step is to actually get the data, fetch the data, and store into our memory variable, which is called gender data. And this is how we do it. First, we read the data as CSV file, and this file is stored in our working directory, so no need to give relevant or absolute path for this. And we'll store as table into a variable called gender data. As table is a, when you say table is basically a table. Let's say the table is basically a table. Okay. Now we are given a question that says, what is the purpose of line rm list equal to ls? When you say this, we have to know that what are possible answers. To look in the web for World Bank dataset, to change the current directory path, to list all the files in the current directory, to remove all current existing objects in R. And this is the correct answer. It removes all the objects in the memory from the R. Second question. For second question, we are told that we need to do the lookup in the data. We have to look in the data and see how it's organized. And it says that if your data is stored as table, you can simply print the object and it will print the nice looking format. Alternatively, you can also use built-in R commands such as str, which allows you to see the structure of the object in R. Likewise, commands such as head and tail will allow you to see the first 6 and last 6 observation of a data frame. Another useful function is dim, which allow you to give number of rows and number of columns in your data set. Take time to explore this data from the commands and others. Now what we're gonna do is we'll explore these data commands so that we understand them better. First step is to print the table. Second step is to structure command. Third step is to head and tail. We can use head and tail as well. Fourth step, we can also use tail. And lastly, we can use dim. We can use dim. Okay, so we'll use these 5 commands to explore data more thoroughly. Let's print out the table file in nicely formatted way, which is gender data. We'll just print it out. Let's see what we get. Gender data not found. Gender data not found. What's happening here? Do we not load the data? I think we have not loaded data yet. That's the problem. Now we have loaded data. It's loading the data now. Here we go. We have the data in our memory. This is one way to do it. Second way is to look at the structure of the data as well. We can do str to look at structure. Somebody may confuse str with string, but we don't mean string. Str doesn't mean string here. It is structure. Okay. I get confused sometimes. And let's see what we have. Gender data. Let's put a gender data here and let's see what we get. This is a structure. See, it has so many columns. Table, 140 rows, 42 140, 442 rows, 63 columns. I don't know what that 140 means. Let's verify what does 140 mean. Dim gender data. So it is 140. So this is the number of rows and this is columns. That's what it means. 63 columns and around 140,000 rows. That's why it took so long time to load actually in the first place. Then we can do is head and tail. Head gender data, and it's going to give me the first in 6 rows from this object. Similarly, we can do tail as well, and it's going to give me last 6 rows. There you go. There you have it. Now, looking at the data, I can tell that this is organized based upon country code and indicator. Using table, I can say that this is based upon country code, country name, and indicator. So second is a correct choice, correct answer. Question number 3. Moving on, question number 3. Now generate table called teenager FR, which contains adolescent fertility indicator for each country year. Please fill in the blank with the correct code. This is our variable which we want to store to. Generate data is our target source, is our source object, and indicated code is this. Therefore, we have to use the keyword filter here. That will filter the table. This is a tidyverse command. Keep that in mind. We can use filter command to filter the gender data and store that into teenager filter, teenager FR, or filtered. And there you go. Let's see what's inside this object, in this table. Let's see how many rows it has. Okay, this has 263 rows and same as 63 columns as original. It has reduced number of rows. What is the equivalent base function of R? I know this. This is the correct answer. Substance is the correct answer for this one. And last question for today. Question number 4. Since we are not interested in any other variables and gender data is quite large, you might want to get rid of of it instead of ask R to keep it stored in memory. Which one is the correct code for getting rid of the gender object data? And remove gender data is the correct answer for this one. And let me remove it as well so that it's not in memory anymore. And just prove the point. Now it's gone. Finally, let's quickly review what we learned today. We discussed about homework exercises for Model 3. We went through from question 1 to 4, learning about how to get a data and store it in memory, how to filter data, and how to remove the data from memory. These are things we learned today. Thank you so much.